All right. So, you know how we're surrounded by all these smart gadgets these days?
Yeah, definitely.
Like our cars that practically park themselves,
Right.
or refrigerators that remind us to buy milk.
Oh, yeah.
It's pretty wild. But have you ever stopped to think about like what actually makes them smart?
It's a great question. And the answer lies in a field called mechatronics.
Mechatronics.
Yeah, it's like, think of it as this awesome blend of like mechanics, electronics, and computing, all working together.
Ah, okay.
Yeah, they kind of team up to create all these super cool systems that power our modern lives.
Hmm. Mechatronics. Sounds kind of futuristic,
It does, doesn't it?
but it's like secretly running everything behind the scenes.
Yeah, pretty much.
So how did this whole field even come about?
Well, like most technological revolutions, it's got like deep roots.
Mm.
And for mechatronics, we can trace those roots back to, the good old Industrial Revolution.
The Industrial Revolution.
Yeah. Back then, innovation was all about mechanics,
Hmm.
leading to all these different engineering disciplines popping up, like mechanical, electrical, civil, and the like.
So like each one was its own little world.
Exactly. Each one had its own, like, specialized knowledge, its own tools, its own way of doing things.
Almost like separate kingdoms, right?
Perfect analogy.
And with its own language and customs and all that.
Exactly. So, things moved pretty slowly back then.
Right. Makes sense.
But then, boom, the information revolution hit.
Okay.
Driven by, the ever-shrinking world of electronics.
Right.
Suddenly, information could be processed and shared, like, at lightning speed.
Wow.
And those once separate engineering kingdoms we talked about, well, they started to find ways to communicate, to collaborate.
So those walls started to come down.
You got it. And in that space, the seeds of mechatronics were planted.
Okay, so the seeds were planted, but how did they actually like sprout into the field we know today? Like what was that aha moment?
Well, it was the realization that, by combining the strengths of each discipline, you could create something truly remarkable, something greater than the sum of its parts.
I did see.
Mechatronics isn't just about slapping some electronics onto a mechanical system.
Uh-huh.
It's about true integration, creating systems where the mechanical and electronic components work together seamlessly.
This seamless integration idea, that seems key.
Absolutely. It's the heart of mechatronics.
So is it safe to say that any machine with a bit of electronics in it is automatically mechatronic?
Well, not quite. The defining characteristic of a true mechatronic system is something called a control architecture.
A control architecture. Okay, what's that?
Think of it as the brains of the operation. It's what orchestrates the interplay between the mechanics, the electronics, and the computing power.
The brains, huh?
Yeah, exactly. It's like the conductor of the orchestra, making sure everything works in harmony.
So is this where the smart part comes in? Are we like giving these machines a brain?
In a way, yes. This control architecture allows a mechatronic system to process information from its environment,
Right.
to make decisions based on that information, and then to actually take action.
Fascinating.
It's not thinking in the human sense,
Sure, yeah.
but it's definitely a level of sophistication that was, like, unimaginable just a few decades ago.
Yeah, no kidding.
Yeah.
So we've talked about the brains, this control architecture, but what about the other parts of a mechatronic system? Like what are the building blocks?
Well, that's a great question and a perfect segue into the next part of our deep dive. But first, we need to take a quick break.
Sounds good. We'll be back in a flash to break down the anatomy of a mechatronic system. Stay tuned.
So it's like taking those separate kingdoms of engineering we were talking about
Right.
and forming like this super powerful alliance
Okay.
where each kingdom brings its own unique strengths to the table.
I like that.
That's what makes mechatronics so potent, so powerful.
This is starting to make a lot of sense, but I'm a visual learner. Yeah. Could you maybe break it down for me?
Of course.
Like what does this control architecture actually look like in practice?
Absolutely.
What are the nuts and bolts of a mechatronic system?
Our source pasted text has this really handy diagram
Okay.
that illustrates this perfectly.
Right.
Imagine a mechatronic system as like a living organism.
Ooh, okay. I like this.
Right. So it's got these things called actuators,
Wait.
which are like the muscles.
Okay.
They're what make things move.
Got it.
So think, motors, hydraulic cylinders, things like that.
So that's the brawn.
Exactly.
What about the brains?
Well, then you've got sensors,
Okay.
which are like the senses, right.
Right.
They're gathering information about the system and
Right.
its surroundings.
Got it.
So, these could be anything from temperature sensors
Yeah.
to proximity sensors to cameras.
So it can sense what's going on around it
Yes,
and kind of react accordingly.
yeah, they're constantly feeding information back to that control architecture.
Right, right. So it's like a whole feedback loop.
It is, it is.
Right.
But what's making the decisions in this loop?
Right. Yeah, that's what I'm wondering.
Well, that's where the digital devices come in.
Okay.
So think, microcontrollers,
Uh-huh.
PLCs, specialized computer chips.
Okay.
These are like the thinking part of the system.
Got it.
They analyze all that information that's coming in from the sensors,
Right.
and then they tell the actuators what to do.
So it's like a tiny computer making decisions in real time based on all this data.
Yeah, based on what's happening around it.
Man, I'm starting to really see the power of this integrated approach.
It's pretty amazing. And then to connect everything, you have what are called conditioning and interfacing circuits,
Okay.
which are like the nervous system.
Okay.
Right. They're transmitting signals back and forth
Right.
between the sensors, the digital brain, and the actuators.
So it's like a complete sensory motor loop
Yeah,
with a brain in the middle calling the shots.
you got it.
Fascinating.
And finally, to interact with us humans,
Right.
there are graphical displays.
Okay.
Like the face of the system,
Yeah.
communicating information,
Okay.
allowing for user input.
This is making me see everyday objects in a whole new light.
It is, isn't it?
It's all so interconnected.
It is. And, the beauty of it is,
Yeah.
Mechatronics, it often operates behind the scenes,
Right.
seamlessly integrating into our lives.
Okay. Enough theory. Let's get practical for a second.
Sure.
Can you give me a concrete example of all these elements working together? Something I encounter every day.
In fact, our source highlights a perfect example, the
Okay.
office copy machine.
Hold on. The copy machine.
Right.
Really?
Yeah.
I never thought of that as particularly high tech.
Well, think about it.
Okay.
To function, it needs to sense the presence of the paper,
Uh-huh.
the position of the paper, the toner levels,
Right.
even whether the doors are closed.
Okay.
That's where the sensors come in.
Right. Right.
Optical sensors to detect the paper, capacitive sensors for the toner,
Oh, wow.
even thermal sensors to monitor the fuser unit.
I had no idea. So that's the sensing part.
Right.
What about the action?
Well, then you've got actuators controlling the paper feed,
Okay.
the drum rotation,
Hmm.
toner application, the sorting mechanisms.
Right.
All these moving parts precisely controlled by the system's brain.
And that's where those digital devices come in.
Exactly.
Making sure the image gets transferred onto the paper. Managing all the different stages of the process.
It's a whole network of microcontrollers and circuits constantly processing information,
Right.
making decisions, directing the actuators to do their thing
Wow.
at precisely the right time.
And the graphical display.
Yeah.
That's how we tell it what to copy.
Exactly.
How many copies we need.
Yep. How many copies? What settings you want?
That's mind-blowing. I never realized how much sophisticated engineering goes into something as seemingly simple as a copy machine.
And that's just one example, right?
Yeah.
Mechatronics it's everywhere.
Okay.
Think about aircraft navigation systems,
Oh, yeah.
guiding planes across continents,
Uh-huh.
car safety systems that prevent accidents,
Right.
robots assembling products in factories,
Yeah.
smart appliances that learn your preferences.
It's incredible how it's become so ingrained in our lives,
It really is.
often without us even realizing it.
Yeah. And, the source provides some excellent links for your listeners.
Who want to delve deeper into specific examples.
Right.
Great. There's a whole world of mechatronic marvels out there.
I bet there is. So we've talked about what Mechatronics is.
We have.
We've seen how it works.
Yeah.
We've even explored some everyday examples.
We have.
But what does the future hold for this field? Like, where does Mechatronics go from here?
I mean, it really is amazing
Yeah.
to think how this field, mechatronics, has just revolutionized so many industries, from everyday appliances
Right.
to these really complex industrial systems. It's just changed the way things work.
Yeah, no kidding. It really has.
And it's not just about the technology itself,
Right.
but how seamlessly it integrates into our lives.
Yeah.
often without us even realizing it.
Right.
That's the real beauty of mechatronics.
Absolutely. But as these systems become more sophisticated,
Yeah.
more intelligent, it kind of makes you wonder, like,
Yeah.
what's next for mechatronics?
Where does the field go from here?
That's the million-dollar question, isn't it?
It is.
I mean, it's something that keeps researchers and engineers up at night
You bet.
because the technology is evolving at such a dizzying pace.
Right.
The possibilities are just vast,
Yeah.
you know? Imagine even more intuitive robots
Okay.
capable of collaborating with humans in ways we can barely even fathom today.
Like almost like partners working alongside us.
Exactly. And think about medical devices
Okay.
that are not only personalized but also adapt to your individual needs in real time,
Wow.
or smart cities
Uh-huh.
that optimize, everything from energy consumption to traffic flow,
Yeah.
making urban living more efficient and sustainable.
It's exciting and a little daunting
Yeah,
at the same time to think about all these possibilities,
for sure.
as we kind of hand over more control to these intelligent systems.
Right.
It makes you think about the implications. Right?
Absolutely. I mean, you've hit on a really crucial point there.
Yeah.
The future of mechatronics isn't just about, technological advancement.
Yes.
It's about shaping a future where these systems serve humanity
Right.
in a responsible and ethical way.
Right.
It's a conversation that needs to happen alongside all the innovation.
Couldn't agree more. Well, this deep dive into the world of mechatronics has been truly eye-opening.
It has been fascinating, hasn't it?
It is incredible to see how this once, kind of obscure field
Right.
is now shaping the world around us,
Yeah.
often in ways we don't even realize.
Absolutely. And for all your listeners out there, I encourage you, keep exploring,
Yeah.
keep asking questions, and keep imagining the possibilities.
I love that.
Because the future of mechatronics, in many ways, is still being written.
And who knows, maybe one of our listeners will be the one to write the next chapter
That would be fantastic.
in this incredible story of innovation. Thanks for joining us on this deep dive.
It's been a pleasure being here. Thanks for having me.